Hello everyone, welcome back. This is chapter 1 of general chemistry. This is where things really start to get fun. This is where we really start to take some stride, pick up some pace, do things the way that I want to do them. Chemistry was honestly my first love. I learned chemistry at the age of 15. I remember I fell in love with chemistry. The way that my teacher, I had a fantastic chemistry teacher in high school. The way that my teacher explained it, drew these sort of atoms and molecules and this and that and everything, grew to a lifelong obsession with the way that chemicals interact and the way that they bond and the way that they do it. And to be honest, you have to be quite perceptive in order to understand chemistry in a way that's meaningful. You have to see it go on in your head. When I talk about organic and chemical processes, I want you to think of the molecules as interacting, and I want you to see it. I want you to see the movement of the molecules, see the electrons, see the orbitals, see everything, and that's what I'm trying to instill inside of you. I want to pass on my visual knowledge of chemistry onto you so that when we get more complex and complex things become easier on you, not more difficult. Who's ready? Yes? Yes, let's do it. We begin with atomic structure, and we begin with a discussion about subatomic particles. But you can't really tell a story of any study without talking about the history of what this study is. Atoms are this postulated idea that the Greeks once thought of, which is the indivisible unit. If I were to take a tree and chop it in half, and chop that log in half, and chop that in half, and chop that in half, and chop that in half, and I kept going, what's the smallest I could go? What's stopping me? Where am I going to hit a wall? And the Greeks postulated this idea of this indivisible unit, and atomos, right? This idea of something that cannot be split. And now we know that that's not necessarily true. But before we talk about subatomic particles, we need to understand that the atom is the central sort of functional unit. We use that word a lot inside of biology. The nephron is the functional unit of the kidney. The, keratinocyte is the functional unit of the skin, right? We talk about how the muscle spindle or the muscle fibers is the functional unit of the muscles, right? The neuron is the functional unit of the nervous system. So we talk about the functional unit. The atom is basically the functional unit of what? The atom is the functional unit of all matter, right? All matter, anything that has mass, anything that you can touch and feel and is tangible and you can do sort of chemistry with and blah, 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 that is the atom. But what are the units of the atom? These are the subatomic particles. What is the first and most important subatomic particle we have? Most important is relative, but I think that we all have a sort of idea. What's the most important one? The proton. What's the most important one in organic chemistry? The electron. But, bless you, in general chemistry, we have the proton, which exists in the nucleus of the atom. We will talk about what a nucleus is in a bit. Has a +1 charge. And this is sort of a +1 electron volt, so you can write a little E charge. And this is E is equal to, the specific number here, and you'll be given it if you need it, 1.6 times 10 to the negative 19th coulombs. Coulombs is a charge per unit time, correct? It comes from physics. I'll leave this over here. I think it's a bit better for me to see it from here. We have an atomic mass unit, and the proton is 1 atomic mass unit in weight. You guys remember this is all a recollection, right? And the most important thing about the proton is that the atomic number is identified or defined by the number of protons. And the atomic number is basically the social security number of that atom. It's the thing that identifies it specifically. So carbon, how many protons does carbon have? Off the top of your head, anyone? 6? Yes. Hydrogen has 1. Uranium has 92. Right? How many does iron have? I don't know. Pull up a periodic table. Right? So the important thing to remember here is that if you change the number of protons, you change the element. You're no longer the same atom. You're no longer the same atom. You're an atom of a different element, right? What is this nucleus we're talking about? In the basic theory of the atom, we have a nucleus and we have an electron cloud, correct? The nucleus contains the protons and the neutrons. Also found in the nucleus. And you can think of the nucleus as the central inner mass of the atom. That's where the majority of the mass is going to be. Right? Also found in the nucleus, mass equals 1 AMU, same as the proton. Charge equals 0. Neutrons have no charge. None. Zip. Technically, the mass of the neutron is slightly higher than 1. Slightly, tiny bit higher than 1. A 1's fine for your reference. And changing neutron numbers doesn't change you as an element, but it's almost like changing your outfit. If I throw on a pair of glasses, now I'm like Saturday weekend Yusuf. And if I threw on like a workout shirt and went for a run, I'd be like cross country Yusuf. And I have this on, which means I'm like whatever this is Yusuf, right? So different number. Do you run here? Different number of neutrons equals same element, right? But different mass. Does everyone know what that's called? Same element, different mass. That's called a isotope. Very good. You guys are sharp. Isotope. So if we have carbon, carbon can be carbon 13, carbon 12, carbon 14. These are all different isotopes. We said carbon has how many protons? 6. So these are mass numbers. And if the neutrons and the protons are adding to the mass, and the electrons don't, which we're going to see in a bit, right? That would be 6 protons and 6 electrons. 6 protons and 6 neutrons. 6 protons and 7 neutrons. 6 protons and 8 neutrons. And this gets us to the idea that the mass number, the atomic mass. The atomic mass is what? Equal to number of protons plus number of neutrons, correct? For any specific atom. For protons, we can abbreviate as P, and for neutrons, we can abbreviate as N. I'm all in frame, correct?
Yeah. You're in frame.
Good. So for any atom, we have a layout on the periodic table that we're able to speak about, and it's different for every single element. We have X, element X. We have a number of protons, and we have a mass number. So this is the element. This is the atomic number, also known as the number of protons. And this is the number of protons plus neutrons, which equals mass. But that is the mass number. We'll talk about the difference between the mass number and the atomic mass. So this is the mass number. And basically, all this is saying is that number of protons plus the average number of neutrons. X bar means average. X bar, average. You guys remember my little shortcut? What does this mean again? Did I ever tell you about that one? Must be equal to. And you guys know this one, of course, right? Approximately equal to, right? Do you guys remember? What does that say? Functional. Very good. And what does this mean? Leads to. Very good. Awesome. You guys are learning the shorthand. It's going to be so helpful. So I promise you it'll be helpful if you pick it up. Oh, do you guys remember these? Exactly. Yeah. That's my gang right there. This is before and this is after. Avant and après. Right? Before and after. It takes some getting used to, but if you do it, it quickens your writing time so much. There's someone on YouTube who just like will not stop commenting about how big of an ego I have. Guys, I'm going to tell you something right now. This is not ego. This is confidence. There's a very thin line between ego and confidence. I know that I know enough, but I also know that I know so little that I actually know nothing. I'm giving you enough of the knowledge just to say that you know enough. I do not consider myself higher than any of you, and I'm 100% sure that half of you in this room will go on to do much greater things than I ever did, and the other half, you will go on to do things that no one will ever know, and you will keep to yourselves, and no one will know about it, and they will still be greater than anything I've ever done. Because I truly, truly, truly believe that with all the time I've wasted, and all of the things that I've done, and all of the ridiculous things I've said to whatever number of people and put myself down, I truly believe that I'm one of the most ignorant people in the room. I actually believe that I know the least. And I truly believe that. Because I've come so far in my journey, and I've seen so much, alhamdulillah, praise be to God, I've seen so much, that it's done nothing but put me down. And I say that with pride. To be put down is to live a meaningful life. I'm very proud of my experiences. I'm very happy about it. But I'm confident that I have the skills and I know what it takes to get you to where you need to be. That's all I'm doing. I'm taking a little step into your life, I'll teach you something, and I'll step back out. Let's talk about the most important subatomic particle to me, the electron. Electrons have what charge? A -1 charge, correct? -1 E, -1 electron volt, correct? Which is equal to -1.6 times, what was the number? Times 10 to the 19th, very good. Sorry, 10 to the -19th, my bad. The mass of an electron is what fraction of the atomic mass unit? 1 over 2,000. The mass of the electron, 1/2000th of an AMU. So if you got together 2,000 electrons and held them, they would be the weight of 1 proton, right? So this means something about the physics of how this all works. You guys remember gravity? Right? You guys know gravity. The Earth has gravity because of how large it is. And we orbit the sun in a gravitational field because of how large the sun is and the amount of mass it has. You ever heard someone be really mean to someone, be like, you got your own gravitational field? That's harsh, right? However, look at this. If the proton is so much larger than the electron, what can we say about the gravitational force between them? Is it dependent upon the mass of one thing, or is it dependent on the mass of both things? It's really dependent on the mass of both things. They are so different in mass, the electron is so much smaller, but they are equal in charge. That goes to say some very important thing. The electrostatic attraction between the proton and the electron is much greater and much stronger than the gravitational attraction. Yes?
What prevents the electron from crashing into the sun, the nucleus?
Crashing into the nucleus? Yeah. The fact that this is what I'm saying. So by gravitational standards, so the question was, what prevents the electron from crashing into the nucleus? By gravitational standards, you would expect it to go around and just crash into the sun, the nucleus, right? But it doesn't do that, because the electrostatic interaction keeps it just zipping around. The electrostatic attraction also has a vector, and that vector has it moving in a specific direction. And also you have to understand that most of the time, unless you're hydrogen, or that first row, the electron also has other electrons that's interacting with. There's a bunch of stuff over there, blah, 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 whatever it is. That's a great question, honestly. I really commend you for asking that question. You're thinking ahead. So most important for charge is the electron. Most important for mass is the proton and the neutron equally. And most important for the identity, the proton. So if something loses an electron, right? Let's say that we have not carbon. Let's say that we have an atom of lithium, right? Or there you go, right? You have an atom of lithium, 3 protons. If this lithium atom were to lose 1 electron, we could write it as positive. So now we have 2 electrons instead of 3. Why do we have 3 electrons in the first place? Every single atom in their base form has an equal number of protons and electrons. From there they can lose, and from there they can gain. Right? So when lithium loses an electron, we can give it a positive charge because now the number of protons outweighs the number of electrons by 1. The number of positive charges outweighs the negative charges by 1. And that leads to a positive 1 charge. Does that make sense? Very good. One second. Sorry, guys, there's a lot going on today. Very, very busy. Everyone get that? Anyone need anything on the board re-explained? Okay, let's move on. Oh, I erased the chapter title. Guys, we gotta restart. We gotta re-record everything.
Wait, should it be recording?
Do you know that's happened before? It's actually happened before because back at Brooklyn College when I taught, the camera used to be like a lot closer to me and a lot further away from the students because they would be in these like stands, these like stand type seats, like an auditorium seat. And one time it just wasn't recording. It was a 3-hour lecture and it wasn't recording. And I did it all in one sitting. Went for 3 hours straight. I had to redo it.
Was it a lecture you at least liked, or was it like
It was biochem, so it was fun. It was good, but like I had to redo it because that was my first year teaching.
the evolution or something?
Yeah, literally. Let's talk about atomic weight versus atomic mass. This is sort of the conversation we were having before. The atomic mass, also known as the mass number, I like to use this instead. Right? Is the mass of a specific isotope of an element. So carbon-14 has an atomic mass of 14. Carbon-12 has an atomic mass of 12. Uranium-235 has an atomic mass of 235, right? Okay. The atomic weight, also known as capital A, which I've literally never seen anyone use ever, is the average of all naturally occurring what? Yeah. Basically atomic masses in their proportions. Someone open up a periodic table on their computer and tell me what number you see above carbon. 12 point blah, 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 blah.
12.0107.
Yeah. So carbon, it'll say 6, and then it'll say 12.0107, you said? So this is majority carbon what? 12. And it's the tiniest bit of 13 and the tiniest bit of 14. And you average all those together with their proportions, and boom, you get 12.0107. Make sense? But by default, if someone says carbon, what's the mass? What are you saying? 12. Right? I might be a teacher sometimes. I might be a runner sometimes. I might be a cook sometimes. I might be sleeping sometimes. But if someone asks you, he, him, what is he? What are you going to say? I'm a student. Because 90% of the time, I'm a student. 99.99% of the time, this guy is 12. So you're going to say he is 12. But if you're talking about a specific isotope, if I picked all of the carbon in the world, and I picked up one carbon atom and said, what is the atomic mass? You would have to look inside of it and tell me the number of protons and neutrons. Does that make sense? Do you guys get the difference? Okay, good. Let's talk about some white people and their experiments. Has anyone read that book, The Man Who Knew Infinity, or watched the movie, Ramanujan? I'm fascinated by that story. It's like picking up on social media again. Do you guys know the story of Ramanujan? He's like a young man, or I guess a boy, who grew up in like what people call the quote unquote slums of India, and he was from like a well-respected family, like socially, but he eventually like grew this fascination for numbers and this and that and whatever it was. But he was never classically trained. He never like learned proofs and formal logic and this and that and everything. But when he saw like a textbook of just theories, just like laws and theories and this and that and everything, he started to just read them and just make the connections himself in his brain in his own way. Like obviously, people speculate it's some sort of savantism, right? That he was just this prodigy of mathematics, and he ended up writing to some of the guys at Cambridge, right? I believe it was the University of Cambridge, some of the best mathematicians in the world, and he wrote down his formulas, and he's like, these are my formulas, like, can you look at them for me? And he actually ended up like writing to them. They read the paper, and they said, there's no way these aren't true. Like, there's no proof on them, but we've run them through all of our like rigorous this, that, everything. There's no way this isn't true. So this whole story started about getting this poor boy from India, not poor as in like, down on his knees, but like he's begging for help. He's like, I have all these ideas and I want them to be out in the world. Like, please help me. So it started this insane arc of getting him over to the UK. It's a beautiful story. You guys should watch. I forgot what channel it was on YouTube. I think it was either 3 Blue 1 Brown but I know Veritasium is on the video. So if you guys. Yeah, it was Fern, right? Fern and Veritasium together. They made a video about this, The Man Who Knew Infinity. You guys should definitely watch it when you get home. Very interesting. It's also a book. A book that they made, this is mine. A book that they made the movie off of. Anyways, let's talk about Rutherford. Rutherford provided evidence that, one, the atom has a nucleus. Am I writing to the sky again? I am. Let me flatten out my writing. And two, that the nucleus accounts for a small volume of the atom. You know the whole atoms are 90% empty space, that whole thing? Yeah, that's this guy. You got that? Yep.
What was the top box say?
He provided evidence that, number one and number two. There's a man named Planck. Definitely recognize that name if you've taken physics. Planck's constant, right? Which we also use in chemistry. Posited that energy, capital E, released as electromagnetic radiation was what? Was what? Releases in, or is emitted in bundles known as quanta, plural of quantum. Sorry guys, I have to get back to something important in between doing this. So what does this mean? Yes?
Does that say positive or positive?
What is it? Posited, to posit something. To calculate this, he said that the energy of a quantum of radiation is equal to h nu. It's not a v, that's a nu. And this is just a fancy way of saying frequency. So E equals hf. Guys, listen up. 1 second. Give me all of your attention. This will for sure get you a point or two on your MCAT. If you know this equation inside and out. People have taken the exam. Who's taken the exam before? Did this come up when you took the exam? Every single time? Every single time you take a practice exam and an actual exam, this equation is there. You will get points on your MCAT for knowing this equation. 100%. The h is the Planck's constant, which is 6.626 times 10 to the negative power of negative, 34. And the frequency is just the frequency of the radiation. But one more thing. You need to also know that the frequency multiplied by the wavelength equals the speed of light. Speed of light. What is the speed of light? 3 times 10 to the 8 meters per second. The wavelength in meters and the frequency in hertz, which is per second. What does per second mean? It means how many waves pass per second, right? So you can say that F equals C over lambda. So another way of writing this equation is that E equals hc over lambda wavelength. That's important. This guy Niels Bohr, what did he do? What a Bohr. B-O-H-R, what did he do? He made the Bohr model, right? The Bohr model was the most rudimentary way of us understanding the way that the atom actually aligns based on Rutherford's calculations. He posited about the hydrogen atom that it was one proton and it had an electron orbiting inside of a circular energy level. Circular orbit. Not energy levels yet. Circular orbit. There's a lot of physics equations underneath this part of the chapter that you're never asked about again. That's like all quantum chemistry and things like that. Not super important. I wanted to take quantum chemistry before I graduated. That would have been cool. But you had to take physics. You had to take Calc 3 before you did quantum chemistry. And I only did up to Calc 2. And from all of those calculations, right, we do a little bit of explaining forward, and we don't really get into the quantum chemistry and this and that and blah, blah, whatever it is. But we understand that these orbits may have energy levels to them, meaning that one orbit may be closer to the nucleus and may be of a lower lower energy, and then higher orbits may be of higher energies, and we're able to sort them based on those energies. And this leads to the idea of an energy level. That electrons will be able to orbit their nuclei inside of distinct energy levels. And as time goes on, the electrons begin to orbit in higher and higher energy levels as we add more electrons to the atom. Does that make sense? This energy level, the distinction of which energy level you're in, is made by identification of a principal quantum number. Equal to, what do we use to describe the principal quantum number? What's the letter? N. N is your energy level, the principal quantum number of any orbital or energy level, but we will go on to identify specific electrons by these. Have you guys heard that theory that you can ask a person like 40 questions and you actually narrow down an individual person in the world by the way they answer 40 questions? So like, how do you do that, right? Well, let's say you ask a question, are you below the age of 35? They say yes. You just wiped out like what, 3.5 billion people, 4 billion people, right? And you just keep asking questions like that until you get down to one specific person. We're going to do that, but with electrons. We're going to be like, are you in this energy level? No, you're in that one. What orbital are you in? What sublevel of that orbital are you in? And within that sublevel, are you up or down? And that's how we're going to identify electrons, right? So think about it that way, that we're sort of using different filters and filtering that we're shaking them to drop to the next level. And we're like, okay, what now, right? So we're going to do that in a bit. This also allows us to understand one more thing. And it's something that I love to explain. I love it. I absolutely love it. You guys ever heard of neon lights? Huh? Yes? What's the phenomenon behind neon lights? Why am I bringing it up now in this discussion about energy levels?
It emits colors based on like how many energy levels it's
Yeah. Anyone else? Anyone else want to add to that? Here's the idea. You have a nucleus. You have an energy level. You have a second energy level. Just because the energy level isn't occupied doesn't necessarily mean it's not there. What element is this, by the way? 2 protons, 2 neutrons, 2 electrons. That's helium. 4-2, helium. 4-2 means mass is 4 protons, 2 electrons, 2. I shoot that helium with a gun. It's an electromagnetic gun. It's an electromagnetic radiation gun, but I shoot it with a gun. And the energy of electromagnetic radiation actually comes and flows right into an electron. That electron absorbs the electromagnetic radiation and does what? Gets super excited. And this electron, I want you to think of electrons as one thing. Okay, this is a rule. I want you guys to literally write this in your notes. Okay, I'm not going to fill it out until you guys start writing. Electrons are just like, write it down first and then we'll fill in the blank. Electrons are just like blank blank. Are you guys ready? Yes. Tiny children. Tiny children. They're zipping all over the place. They don't want to go home. They leave whenever they want. They come whenever they want. They cancel everything out. All the positivity is gone because of them. Right? They're just tiny, tiny children. The more space you give them, the happier they are. You just took that child and gave it cocaine. Right? That's basically what you did by shooting that electron with electromagnetic radiation. Now it's super excited. It's whizzing all over the place so high speed that the first energy level can actually no longer contain it. It's not big enough for this electron. It's not enough energy for the electron. So the electron does what? It graduates. The electron undergoes an energy level transition to the second energy level. And now we have an electron that's excited in the second energy level and an empty first energy level. Whenever you have, because I will tell you now that we're going to look in the future. We'll look in the future, don't worry. The first energy level holds 2 electrons, right? Max. The second energy level is filling before the first one is filled. That means someone is excited. Some electron in there is excited, right? And we see that. It jumped up the energy level. Now, if it absorbed radiation going up, it's going to release radiation coming down. When the electron finally crashes back down to the first energy level, it's going to come down. And since we're going from a higher energy level to a lower energy level, we have to release energy in the form of visible light. This is a whole part of the reason that you run a current through neon and it spits out light in a bunch of different colors. Question in the back? Okay. Yes?
Wait, I just want to clarify. Every atom has like numerous amount of like energy levels, but they're just not being used.
Sometimes,
Okay.
yeah. I don't know. I'm not an atom. Don't ask me.
Okay.
That makes sense? And you literally write this like that. This is very different than what? The color that comes out of what? Does anyone know where I'm going with this? Who has watched my videos before? What color do I love to talk about that has to do with transitions? I just gave it away. Transitions? Transition metals. When you make compounds of transition metals, you dissolve them inside of a fluid, inside of a solvent, they turn colored. Why does that happen? I'll tell you one thing, it's not this. It's not that. There has to be something else that's going on. We'll talk about it. I'm debating on whether or not I want you guys to not write during this next part. I'll let you decide. We're going to talk about quantum mechanical models and how to identify specific electron numbers and specific electron places. If you're not good at this, put your stuff away. If you're okay at it, you can continue taking notes. I will let you decide. Because I do think you can benefit from just watching me actually draw out the whole thing and explain it. So suit yourself. Let's talk about quantum mechanical models. I will not take questions until the end. This is a relatively long portion of the chapter. It's nothing against you, it's just I don't want to mess up my flow. Quantum models arose out of the need to accept the fact that atoms can have more than one electron. And because they have more than one electron, those electrons are going to repel. And the repulsion of the electron inside the electron cloud is going to cause certain things to happen. Why don't the protons in the nucleus repel? Do they repel? Do they? Yeah, they do. It's holding them together. There are nuclear forces. There are nuclear forces that tie the nucleus together. We need to know that electrons move rapidly in probabilistic areas called orbitals. And these orbitals are localized units of space around the nucleus. I'll give you a couple rules about orbitals. Number one, every energy level has access to as many orbitals as its number. The first energy level has access to 1 orbital. The second energy level has access to 2 orbitals. The third energy level has access to 3 orbitals. Number 2, orbitals graduate in a set order. S, then P, then D, then F, then you don't need to know. S, P, D, and F. There's 4 orbitals there. How many energy levels are you covered for? 4. But who is the smart one in the room? This one's not going to get unlocked until energy level 5. You're not going to unlock this until you fill up 5s for the people who are ahead and have studied this before. Number 3. Bless you. Each orbital has, this is important, 2 more sublevels than the one before it. Two more sublevels than the one before it. What is a sublevel? Sublevels hold 2 electrons. Take these 4 things and dedicate them to your memory, because this explains all of quantum mechanical models. Every energy level has access. Okay, if you can't read the board, record me. Literally, take your phone out and record me. And you can watch this later. Every energy level has access to as many orbitals as its number. Energy level 1 has 1, 2 has 2, 3 has 3, 4 has 4. Orbitals graduate in a set order, S to B to P to D to F. Each orbital has 2 more sublevels than the one before it. P has 2 more than S. D has 2 more than P. F has 2 more than D. Sublevels hold 2 electrons each. The S orbital has 1 sublevel. The P orbital has? 3. D has? 5. F has? 7. Which means the S orbital can hold how many electrons? 2. P can hold? 6. 10. 14. Understood? Good. I will draw you a quick diagram. It will be complicated, and you don't need to copy this down, but I want you to see it. Anything on my phone? Okay. I get so scared. I think I did turn on my airplane mode this time, but I always get so scared when someone looks at my phone, because I told you that story about how I was lecturing and then my mom called me and it just flashed and cut my whole video, and then, oh my God. I love my mom though. I couldn't fault her for that one. My mom's out of the country right now. Watch this diagram. Carbon has how many electrons? 6. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Carbon's right here. I told you that the first energy level, n equals 1, can hold 1 orbital, which is S, and it has 1 sublevel, which is 2 electrons. 2 electrons also corresponds to 2 protons, correct? So this is the first energy level, and that's how the periodic table is arranged. It's arranged by energy level, correct? This is going to be your second energy level. And you can see that the second energy level is actually assorted in blocks by the orbitals. So the second energy level has the s orbital and the p orbital. The s orbital has 1 sublevel. The p orbital has how many more than the s? 2. We have 1, 2, 3 sublevels. How many sublevels total? 4 between the s and the p orbital. Each of them hold 2. That's 8. 1, 2, 3, 4, 5, 6, 7, 8. And look at the way they're arranged. 2 on this side, 6 on this side. S orbital filling, p orbital filling. Remember how I said they graduate in a specific way? You fill the s, you fill the p. Do you guys now see how the periodic table is arranged? Do you guys get that? Is that a good explanation? Yes? Okay. Carbon is right here. Carbon has a nucleus. 1, 2, 3, 4, 5, 6 protons. 1, 2, 3, 4, 5, 6 neutrons. It's not bad. Carbon has a first energy level, and I'm doing a cross section. Okay? I'm going to cut straight through the carbon atom. Not actually, it'd blow up the whole room, but I'm going to cut through the carbon atom. I'm going to take a CT scan of the carbon atom, right? Cut it this way. You'll be able to see a slice of the orbital in the first energy level. This is which orbital? The s orbital, because it's the only one that the carbon atom has. And the orbitals are actually integrals of wave functions. If you guys want to look into that, like there's a whole like study of like the wave function, the probability of the electron being in a specific place, and the wave function of like the p orbital. The psi wave function of a p orbital actually looks like this. So, and this is the center of the atom. So you have the highest probability near the center and then thinner near the edges. So that would make for something like a sphere if you integrated that. And then the psi of the p orbital would go like this. And has the lowest probability in the middle and the lowest at the edges. So low at the middle, bigger like this and bigger like that. That's how you get the p orbital. That's the wave function. You integrate that and you spin it around the axis, right? Which is why the p orbital isn't really this. It's more so like if you can imagine a 3D version of that, because it's the integration of that, right? People have done calculus, spin that around the axis, right? Okay, anyways. S orbital. That has 1 and 2 electrons whizzing about in whatever direction they want, in any area within that entire region. And if you isolate its position, you can't know its momentum. And if you isolate its momentum, you can't know its position. This is known as the Heisenberg uncertainty principle. On top of this first energy level, we have a second energy level, correct? The second energy level goes further out than the first. So the s orbital of the second energy level is going to encompass that. And is it full or not? Yes, because we're further along and we have more electrons. How many electrons does this have? 6 protons means 6 electrons. So let's fill the second energy level, s orbital. The s orbital of the second energy level is full. Now where do we go? We graduate to the p, because orbitals graduate from s to p to d to f. So the p orbital, like I said, you would just need to know this unless you're a quantum physicist who derived this equation himself. One. And how many sublevels do we have in the p orbital? 2 more than the last one, so we have 3. They're going to orient themselves to be as far away from one another as possible. So that's going to be the x-axis, y-axis, and the z-axis. And in and out of the board, if you can imagine. Do you guys see that? Now, how many electrons inside of this? 2, right? We're not completely done yet. So we're going to put 1 in one of them and 1 in another. So that's, can you guys kind of see that? Can you guys visualize that in your head? Make this 3D. That's a cross section, make it 3D. Can you guys imagine that? Yes? No? Who can't? Because I couldn't when I first learned this. Who can't? Be honest. You can't really imagine it, right? But do you guys, if you can't imagine it, can you see that this is sort of the way that it's organizing itself? The electrons are organizing into as far away places as possible. This is the whole idea of the quantum mechanic model. Does that make sense? This is sort of where I start to lose people a little bit. But if this doesn't make sense to you, writing it down will. Okay? So let's start writing it down. The quantum numbers are our way of understanding this. I feel like one of those crazy, yeah, have you guys ever gotten those, like, recommended those crazy physics videos on, like, YouTube, where you see the guy, like, filling the board with, like, all those equations? This kind of feels like that. This is my version of that. Actually, my version of that is when we do glycolysis. There's a picture of me, like, standing there with, like, a peace sign up, and it's just, like, all of glycolysis filling the board behind me. It's funny. Quantum numbers are ways of understanding this, and it's a way that we actually put a real ID on an electron, a single electron. One electron has one set of quantum numbers. No other electron can have it. Here are your quantum numbers, which are basically ways of us identifying specific electrons. You guys following? You guys like this? I'm very passionate about chemistry, so sometimes I teach very fast, and it doesn't make that much sense. If that ever happens, please stop me. You have n. What do we call n? I said it before. The principal quantum number. Each of these answers a question, and we'll write the questions on the side. We did this in class today, in Arabic class. We wrote something, we said, what question does it answer? Right? L, beautiful name, azimuthal. The azimuthal quantum number. M sub L is the magnetic, killing it. And MS, spin. Believe it or not, instead of asking 40 questions to get to an electron, you can ask 4. Who knows what questions these things answer? N answers what energy level? What state are you in? Right? L answers what orbital? What city in that state? ML answers what sublevel? What street in that city? Spin quantum number is the spin, which we'll talk about. What house on that block is your full address? The state, the city, the street, the number. Getting more and more specific as we go down. And that's not a bad analogy. That's state, city, street, number. And you'll see how it works. But before that, we need to know Hund's rule. Hund. H-U-N-D. Is it Hund or Hund? I don't know. Hund's rule. What's a word that I pronounce weird? Have you guys ever heard me pronounce anything weird?
Ependymal cells.
Oh, ependymal cells? Yeah. Anything else? I pronounce a lot of stuff weird, I think. Oh, I heard someone say glomerulus. Is that glomerulus? I think it's glomerulus, you know. Long Island, I say weird. I like swallow my G. Long Island. And then like important. Important, right? Very important rule here. Hund's rule says that electrons fill sublevels one by one to avoid brushing shoulders. Organic chemistry is really, when we get there, a story of electron repulsion. Electron attraction and electron repulsion. Electrons naturally repel one another. So when we have sublevels, like let's say in a p orbital, so n equals 2, because we have to have 2 energy levels to have a p orbital. L equals I don't expect you to know this yet. It's going to equal 2, right? Or sorry, hold on. 1. Ugh, rough. So the p orbital, this is also known as the 2p orbital. So the p orbital in the second energy level is called the 2p orbital. Looks like 1, 2, 3, because that's 2 more than the s, which has 1. If I'm going to fill this with 4 electrons, they're going to fill in what way? Are they going to fill like this? No, they're all way too close together. There's an easier way to do this. They're going to fill like this sequentially. If we start at 2p, what's the 2p block? It's going to be your boron, carbon, nitrogen, oxygen. It's going to fill like that in that order. In that order. You guys got that? Yes? Good. Any questions? Oh, we're pretty good on time. Not going to lie. So let's do some practice. And let's figure some stuff out. So we wrote what they are. We wrote what question they answer. Now I'm going to answer the question of what are the possible numbers we could have for this? There's always a second. I don't know. Okay. What's the domain? N could be equal to a possibility from 1 to 2 to 3 to 4 inclusive. It is an independent value. And it is the only independent value. Other than MS. L has a domain. N minus 1. N plus 1. Actually, hold on. I want to say that a different way. Here we go. It has a domain from including 0 to n minus 1. Sometimes n minus 1 will be 0, so it'll just be 0. We'll talk about what that means in a second. Make sense? And what do I mean by independent? This one's independent because it has its own numbers. This one's dependent on n. This one's dependent on L. Goes from negative L to L. Integer values only. That's easy because it has an L in its name, the magnetic number. MS is also independent. MS is one of two things. Negative 1/2 or positive 1/2. You know how long it took me to learn how to draw these? It took me so long to learn how to draw those. I used to draw them like this. What does that mean? The azimuthal, that's the one that trips people up, really. Because let's say that your n is 1. You're in the first energy level. What orbital do you have access to? S, which will have a number of n minus 1, which is because we start at 0, right? The s orbital is denoted by L equals 0. So L equals 0 means s orbital. N equals 2, the L can now be 0 or 1. But can it be 2? No, because it stops at n minus 1. Does that make sense? And this corresponds to the s orbital and the p orbital. I'm wearing the craziest outfit right now. I'm wearing a thobe, and I have Uniqlo sweatpants under these, and I'm wearing Timberland boots. Because I did not bring other shoes to wear in the cold weather from New York. These Uniqlo sweatpants are fire, though.
The white sweatpants?
Huh?
Is the white
No, the black ones.
Okay, we think we're rocking the same.
Yo, for real?
Yeah.
Give me some of that. Do you guys get that? Whole thing about L? Did anyone here watch Death Note? Shout out to L, man. Shout out to my boy. All right, L. Then ML is dependent on L. How? Let's take a look. Am I here? Am I in frame? Okay. ML is dependent on L for a reason. Let's look at L equals 0, L equals 1, and L equals 2. L equals 0 corresponds to which orbital? S. You will eventually just memorize this. L equals 1 corresponds to which orbital? P. L equals 2 corresponds to? D. The S orbital has how many sublevels? 1. L equals 1 has too many. P orbital has how many? 3. 2 more than the one before it. D orbital has 5. 1, 2, 3, 4, 5. You number them based on the L. And the middle one is what? 0. 0, 0, 0. Because, why is the middle one 0? Well, this goes from negative L to L, and in the first domain, L is 0. So it goes from 0 to 0, it's 0. And left and right, you go positive and negative. Negative 1, 1, which is why you get negative L to L, negative L to L. And then here go negative 1, positive 1, negative 2, positive 2. So it's not necessarily a distinction within the realm of chemistry. It's more so if you were to put this down on a sheet of paper and I count sideways, what position am I at? And yes, you can say PX, PY, PZ. I don't care about what you say. Okay? I care about getting you a good grade on this test. Anyone ever met anyone who's just like cracked at the MCAT? Like me personally, I'm not. I had to study for 6 months to get a 521 on the MCAT. I have a roommate who studied for 10 weeks and got a 525. Cracked. Cracked. But he is quite literally one of the most academically intelligent people I've ever met in my entire life. He played Clash of Clans every single night in bed when we were in medical school and was yelling at his friends on video games like every single night. There was never a night that he wasn't on video games while we were knee deep in the third year of medical school. Shout out to Dylan Davey, man. What a legend. By the way, this is the last thing on this chapter. We're almost done. Do you guys get that? When these fill up, this is the fun part. This is the really fun part. When you fill up a sublevel, you're able to fill it up with 2 electrons. One of them can go up, and one of them can go down. Which of them do you think is the positive 1/2 and negative 1/2 of the MS? The positive 1/2 is the one that's going up, and the negative 1/2 is the one that's going down. Now, let's do something fun. You guys ready to have some fun? Are you? Okay. Close your notes. No looking, no cheating. I want to know who's really got it. Aren't I so much happier teaching this subject? I love it, man. I feel the energy coming back inside of me. It might also be the Celsius. Who knows? Okay. I am going to give you an atom. We have boron, carbon, nitrogen, oxygen, fluorine, neon, helium. Let's take a look at oxygen. So this is the 1 energy level and the 2 energy level, right? So the 1s orbital has been filled by how many electrons can fit in the s orbital? It only has 1 sublevel, so it can fit 2. The 1s orbital, which is the only orbital that it has s orbital. It'll fill with 2 electrons. Because oxygen has how many electrons? 2, 4, 5, 6, 7, 8. 8 electrons, right? So we have to get up to 8. This is how the periodic table is organized. So we filled up the 1s, and energy level 1 only has access to the s orbital. We move on to energy level 2. We say, hey, can we put some electrons in here, right? 2 says, sure. Feel free. What do I have to give you? I have an s orbital, but I also have a p orbital. My s orbital has enough space for 2 electrons. My p orbital is a bit larger than my s orbital, which means it has how many sublevels? How much more space do we need? 4 more electrons, correct? How do we place them? We go 1, 2, 3, 4. When you're writing this later in the periodic table chapter, when we do this, we're going to write this as 1s, 2s, 2p, and we'll write how many electrons fill each of them. 1s2 is full, 2s2 is full, 2p4 is what we're up to. Make sense? Yes? I want you guys to give me the full quantum number set of this electron. From N, L, ML, and MS. A lot of that is already figured out for you. I'd say all of it is figured out for you. What's the N? 2, it's right there. L refers to what? The orbital. And the orbital is going to be the p orbital, which is the s orbital is 0, the p orbital is 1. Does that make sense? Are we allowed to have L equals 2 with N equals 1? Yes, because the domain of L ends at N minus 1. We can't go above that, but we can have it. It is N minus 1 inclusive. How do you say exclusive? It would be this. Or inclusive and exclusive. I think that's more mathematically proper. ML. Remember, this is the one where you just drop them. 0 in the middle. Thanks for stopping by. -1, +1. So now this is a -1. MS. Isn't that easy? So much simpler than everyone makes it out to be. Does anyone think this is easier now that they've seen it? Who thinks it's easy? Who thought that was helpful? Good. Amazing. Yes.
Can you explain L one more time?
Of course. Let's explain L one more time. In atoms, we have energy levels. These energy levels have orbitals. These orbitals have sublevels, and these sublevels contain electrons. Every energy level unlocks you the key to another orbital. So if we have energy level 1, we have orbital s, and we have sublevel 1, and we have electrons, we can fit 2. If we have the second energy level, we have S and P. We have 1 and 3. We have 2, 2, 2, and 2, which equals 8. It's the whole idea of 8 octet rule, right? That whole thing comes from here, right? Does that make sense? We want to be able to display L in terms of what it's coming from. We want to be able to describe this in terms of that. So it makes sense to set this as our baseline because we build off of it. So we set this number as a neutral. We set it as a neutral. I don't know why they didn't just call it 1. I have no idea, right? But since we set that as a neutral, every single thing above that is going to add on to that neutral, but it's going to lag behind the S or the N by 1. So we're going to start at 0. That's the beginning of our domain. And the highest we can possibly get within an energy level, within a specific energy level, is that energy level's number minus 1. N minus 1 for N, let's do N minus 1 for N equals 4. That's going to be 3, right? If we have S, P, D, F, we have 0, 1, 2, 3. That is the F orbital. L equals 3 would be the F orbital. Does that make sense? Yes? Or are you just saying that?
No, it makes sense.
Okay. Don't call me sir. That's weird. I hate it. I remember one guy in my first class used to always call me professor. Oh, right in the chest. I was still 23, man. Professor. I don't want your respect, man. I eat dinner with you. I break bread with you. I'm going to smack you. Are we good? We're going to upload a video doing practice questions about this. I think we should make that a separate thing. We're going to do practice on this along with the next chapter, which we're going to keep teaching. If you guys need to take a break now. The beginning is just explaining how the periodic table is organized and how we got to where we got, but we have to keep going because I don't want to keep you here all night. Thank you guys so much for watching. Please check the link in the description below. And for ways to support the channel, we also have a Discord channel, server, whatever you call it. Please join. I'll see you guys later. I'll do it.